All right, today we are starting section 1.3, midpoint and distance. So today our main focus will be midpoint. We are going to find the lengths of segments in a coordinate plane. Our warm-up is to find a point between A and B. So that means we'd have to give the coordinates of it. You can call it anything you want. I'd probably call it point C, but we're just giving the coordinates of a point that would be in between A and B. Anybody come up with one? Kobe? 0, 5 would be in between those points. If you needed to draw yourself a little grid to help you visualize that, that's fine. But -3, 5, and 7, 5 would lie on a straight line, so you would just need to pick some point in between them. Okay, other options would be something like -1, 5 or 5, 5. All of these would be options. We should name it. You don't necessarily have to. Questions about number 1? Okay, who found the average of -11 and 5? Oh, that's not what I'm coming up with. Maddie?
-3.
-3 is what I came up with. To find average, what do we do? Maddie?
Add both of the numbers and then divide by how many numbers there are.
Good. Add the numbers, divide by how many there are. In this case, that would be 2 numbers. So we would get -6 divided by 2, which is -3. All right, on number 3, we had to solve. Kobe, you have a question? You're going to help us. How'd you come up with 3? Good. We got to multiply first. Multiply by 2. And then what did you do after that? Good. So I agree x is equal to 3. Questions on our warm-ups? All right, let's get into our notes. Midpoint, the point of a segment that divides the segment into 2 congruent segments. You probably could have guessed that from its name. It is the point that is exactly in the middle. So for this diagram, if M is the midpoint, that means which 2 segments are congruent to each other? I think I heard it. AM is congruent to MB. Since I'm talking about congruence, I am putting the line segment over the top of them. We could say that their lengths are equal, but in this case we're talking about the segments themselves being congruent. And like I did on the diagram when we were talking about the homework, if we are talking about congruence in a diagram, we are going to see these little marks. We call them tick marks. They look like little dashes. Any segments that have the same number of tick marks on them are congruent to each other. So that's our shorthand for marking it in a diagram. A segment bisector is going to be a point, ray, line, line segment, or a plane, that intersects a segment at its bisector or its midpoint. Segment bisectors get a little confusing because we have two objects we're talking about. One object is doing the bisecting. That could be the point, ray, line, line segment, plane. It does the bisecting. The other object is what is getting bisected. To be bisected means it's getting split into two congruent pieces. Okay, so if we're looking at this diagram, what do you think is doing the bisecting? Line L, good. So in this diagram, line L is the bisector. It's doing the action, it's bisecting. What is getting bisected? Segment AB is getting bisected.
So it's whatever line it goes to?
Yes. And normally you would have to either be told that in the directions or your diagram would have to be marked. So again, this one's going to get marked with AM congruent to MB. Bless you. Okay, up next we've got this question. I don't think it's necessarily in your notes. You can write it down. You do not have to, but we will talk about it. Why is there no such thing as a line bisector? Notice that we specifically talked about a segment bisector. So why is there not a line bisector? Because a line goes on and on and on, that really is the reason why there's no line bisector. So I could put a line up here, but remember a line has arrows on both ends, and I could find what I think to be the middle of what I've drawn here. So I could say, well, it looks like that's maybe about in the middle. So I could put a bisector through here. But then I could come along and be like, well, a line goes on and on and on, so we could extend it out further. And now this point is no longer in the middle. Okay, so there is no such thing as a line bisector because a line continues on infinitely in both directions. A line continues infinitely in both directions. So anytime you think you found the middle, we could extend it on further. Example 1, on our diagram, we are asked to find the length of RS. Sometimes when I am told to find a length, I kind of like to mark it with a curly bracket or highlight it, draw a line over it. So from R to S means I'm finding this whole length here. You'll notice that we do have these little tick marks that I'd mentioned in our diagram. So does anybody know what RS is going to be, John?
43.4.
43.4. How'd you get that?
I added 21.7 times 2.
Good. So we know that T is a midpoint if these are marked as congruent segments, or we know that RS is getting bisected in the middle there. So we have two equal segments. We add them together or multiply by 2. Either way, RS is 43.4. Questions, concerns? Easy peasy. Ready for another one? All right, on the back, we've got example 2. We are told that M is the midpoint. They also labeled these segments as being congruent for us. We are asked to find the length of VM. Before we can find the length of VM, what do we need to find? The value of? No, we actually don't need to know the length of VW first. In order to find the length of VM, I need to know what X is. If I know what X is, I can plug it in and solve. And Ariana told us how to do that. Set them equal to each other. We know that they're congruent, so they can be set equal to each other. This is why we don't need to know the length of the whole thing. Yes, if we knew it, we could use segment addition like we did yesterday. That's another way to solve the problem. But they didn't tell us the length of VW, so we cannot go that route. Questions about why we set these equal to each other? Do we have questions about it, or are we all good with that? Okay, now that they are equal to each other, now that they're set equal to each other, I need to solve for X, so what do you want to do? Micah? Good, we can subtract 3x from both sides. 4x minus 3x leaves us with x. Last step. Add 1, x equals 4. Again, if you did not show the minus 3 minus 3x, the plus 1, that's fine. I should still see that you're solving. Okay. Am I done with this problem? No. What do I still need to do? Plug the 4 back into x. Does it matter which one I plug into? Not really, because they are both the same. Okay, so they asked for VM, so I'll plug it into the VM. But really, it doesn't matter if these are congruent to each other anyway. 4 times 4. Minus 1. Wonderful. The length of VM is 15. Number 3 is similar to number 2 in the way that we're going to set it up. It's a little bit different because this time, what do they ask us for? Oh, it's not really any different. They asked us for the other side of it. So they asked us for KL instead of the front side of it. So take a moment to complete this one. It's set up exactly like the last one. We'll talk about the answer in just a moment. All right, how did we start the problem? Set them equal to each other. If we have a midpoint, these are equal. So I'm guessing the problem happened when we started our algebra steps. We need x's together and constants together. Plus 3x. Okay, so one way to do that would be to move the x's to the right. A lot of people like that way because it keeps the x positive. It's not the only option, but it's one option. That leaves us with 8 equals 5x plus 5. Next step. Subtract 5 from both sides. Okay, when we do that, what do we get? 3 equals 5x. Next thing I need to do? Divide by 5. Okay, so that's not pretty, but it's not terrible. X is equal to 3/5. Who got that part? Okay, good. All right, so once we have x, we have to plug it back in. Now again, you could plug it into either expression because they should be the same thing. But I'll plug it into KL since that's what they're using. 2 times 3/5 plus 5. 2 times 3/5 as a fraction is what? 6/5. Good. I would kind of leave it like that. Or you could, in this case, turn it into a mixed number. It might be easier in this case to go the mixed number route. I rarely recommend that. But as a mixed number, what would this be? Well, before we add them together. If we change 6/5 to a mixed number, what is it? How many times is 5 going to 6? How many are left over? Okay. Sorry, I might not have been as clear as you wanted about what I wanted. And then some people did say, then once we add them together, we get 6 1/5. That is the same as I also heard 31/5. That would also be fine. Should be the same as 6.2. So if you got that, that would be the same thing. Did anybody get this answer? A couple people did. Okay. Good. So yes, we might have some problems where we get fractions and or decimals. That's fine. They're numbers too. All right, midpoint formula. Maybe you've seen this before, maybe not. If you have coordinates for A and B written as x1, y1, x2, y2, the midpoint of AB is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is still an ordered pair. It's still a coordinate, a point. It should still have an x, comma, y when you're done with it. This is how we find a midpoint if we are given coordinates. They marked the midpoint for us on there. Yes, you probably could just find it on the graph using your coordinate plane, but let's go ahead and practice using the formula. So our midpoint M is going to be found by adding our x coordinates of P and R. What are the x coordinates? Okay, -2 plus 4. All of it gets divided by 2. And what about my y coordinates? 5 and 3 also gets divided by 2. -2 plus 4. 2 divided by 2 is 1. What about 5 plus 3? 8 divided by 2 is 4. So those are the coordinates for M, my midpoint. Hopefully that's easy. Please don't forget that formula. Questions, concerns about number 4? I know we went through it pretty quick, but hopefully that's okay. All right, we'll move on. The endpoints of segment CD are -8, -1, and 2, 4. Find the coordinates of the midpoint. This is just like number 4, except they didn't give us a graph. So you can do it with or without a grid or a coordinate plane. It's the same idea. So our midpoint, we first add the x's. What are they? -8 and 2 divided by 2. It's always divided by 2. What is -8 plus 2? -6 divided by 2 is -3. What are my y coordinates? -1 plus 4. Again, divided by 2. What is -1 plus 4? Hopefully we're saying 3. We shouldn't be saying -3. All right, and then 3 divided by 2. 1.5, you could leave it as 3/2, 1.5, any of those would be fine. There's our midpoint. Questions, concerns? Okay. You should have this on your homework sheet, but if not, here it is. Our homework's out of the book, page 19, 11 through 20, and 24.